objective of this experiment is to determine the velocity of a metal ball fired from a spring-loaded gun ballistic.
Hi, my name is Nur Akila Zuleika, and today I'm going to explain about methodology for experiment 5. In this experiment, the initial velocity of a metal ball fired from a spring-loaded ballistic pendulum was determined by measuring the masses involved and observing the maximum height reached by the pendulum after the ball was captured. Using the principles of conservation of momentum and energy, with repeated trials carried out to obtain an average value and reduce experimental uncertainty.
Answer for question 1 is the average initial velocity of the metal ball is 51.2 meter per second with an uncertainty of 0.5 meter per second. Question 2, the answer is conservation of linear momentum and conservation of mechanical energy.
For the results of this experiment, the mass of the metal ball was measured as 9.3 times 10 to the power of negative 3 kg, and the combined mass of the ball and pendulum was 0.0173 kg. 10 readings of the maximum height reached by the pendulum were recorded after the ball was fired. The measured heights range from 0.077 meter to 0.084 meter. Using this heights value, the velocity of the pendulum immediately after impact, which is u, was calculated for each trial. The calculated values of u range between 1.987 meter per second and 2.168 meter per second. From the 10 trials, the average values of u was found to be 2.049 meter per second. Overall, the results show consistent readings across all trials, indicating good repeatability of the measurements.
For discussion, the objective of this experiment was to determine the initial velocity of a metal ball fired from a spring-loaded gun using a ballistic pendulum. The experiment is based on two main principles. The first one is conservation of linear momentum, which applies during the inelastic collision between the ball and the pendulum. The second is conservation of mechanical energy, which is used when the pendulum swings upward after the collision. For our findings, the pendulum reached a small but consistent maximum height after each collision. From this value, the average velocity of the pendulum after impact was 2.049 meter per second, and the average initial velocity of the metal ball was 51.225 plus minus 0.464 meter per second, showing that the results were consistent. However, there were several sources of error, such as energy loss due to air resistance, friction at the pendulum pivot, and the energy loss as the sound and heat during the collision. Measurement uncertainty also affected the result. To reduce this error, friction should be minimized, measurements should be taken more accurately, and more trials should be conducted. Thank you.
So, in conclusion, the objective of the experiment was successfully achieved. The initial velocity of a metal ball fired from a spring-loaded gun was determined by using a ballistic pendulum method. By applying the principles of conservation of linear momentum during the inelastic collision and conservation of mechanical energy during the pendulum's upward motion, the initial velocity was calculated indirectly from measurable quantities. Based on 10 experimental trials, the average velocity of the pendulum immediately after impact was found to be u equals to 2.049 meter per second. Using this value, the average initial velocity of the metal ball was v equals to 51.225 plus minus 0.464 meter per second. The relatively small uncertainties indicates that the results are consistent and reliable. Despite minor energy losses due to friction, air resistance, and the inelastic nature of the collision, the experiment demonstrates good agreement with theoretical expectations. Overall, The experiment effectively illustrates the application of momentum and energy conservation laws in determining the initial velocity of a projectile.
If the sun refused to shine,